If you are in Gradescope, assuming you have already grabbed the PDF, normally it'll be scanning your own PDF, but in this case, we've already got a PDF file over here. So I want to assign questions to page, and go to this assignment. I'm always going to submit a PDF, not images, because images are less easy for me to read. So please always be submitting PDFs and not images. I'm going to select the PDF, which is right here on my desktop. There it is right there. Where'd you go? Fine, it's on my desktop. There it is. So, yep. And then you have to also, it seems silly, you have to like select it and then upload it, whatever. All right, so then you've got your PDF and all of the questions you want to assign to it. So question 1 is over here on page 2. Easiest way, so you can do it the long way. You can click the question and then the page, and then the question and then the page, and then the question and then the page. But it takes, right? So if there's a lot of questions and pages, you might not want to do that. Question 2, so I can zoom in here to see that on page 3, I've got question 2A and 2B. So I can hold shift, click question 2A and 2B, and then click on that. Now, the only thing you have to do is if you do that, you have to hit escape afterwards. And look, it looks like I accidentally got question 1.4 on there as well, right? Question 1.4 isn't on, or question 1D isn't on page 2 and page 3. So I'm going to close that one so that it's no longer on there. And then I want to put questions, let's zoom in here. So on page 3, or sorry, page 4, I've got 2C, 2D, and 2E. So I'm going to hit escape just to make sure I don't have anything selected, right? Nothing's selected anymore. And now I'm going to hit shift, click that, and then click on the page that they're on. Now notice, if they're still highlighted, it means if I click on another page, they will also get assigned to that page. So I press escape to unhighlight them, and then I go on. So on this one, I see I have questions 3A, 3B, and 3C. So I'm going to click shift, 3A, 3B, 3C, click over there. And then escape to unselect them, and we keep going. So looking here, I see questions 3D and 3E. So I'm going to do 3D, 3E. Now, if you just click and click, then when you click on the next one, it automatically deselects the previous one. So you can just do it that way. On this last page, let's see what I've got here. I've got question 4A and 4B. So I want both of those on there. And then finally on the last page are questions 5 and 6. So again, escape to deselect the ones I've selected, shift to select more than one, and then click on right there. Chat here. 2A and 2B have 2 pages. Let's see. You are correct. Excellent. So if you see something that has more than 2 pages, right, you can just click the little X's there to get rid of them. And if something ends up having accidentally more than 2 pages, it's not like a huge deal. The reason I ask you to do this it's mostly for the midterms that you're going to be submitting, just so that I don't have to search through all of the pages that the midterm has and be able to find things. So, but I really do want you to do this because it's going to make my life easier. It's not really any easier for you to do this. I'll be perfectly honest. It is so that I can grade your midterms relatively straightforwardly. It's also so I can grade your homework too, right? Because for the homework, there are usually a non-insignificant number of questions asked, and to sort through them does take time. So yes, it's mostly about saving me time, to be perfectly honest, but I have a lot of grading to do. So please do assign questions and pages. If you don't, I will send you an email asking you to do it before I grade it. And then finally, once you've assigned all the questions and pages, you submit it. And page 1 doesn't have anything associated with it. That's fine, right? Because there aren't any questions on page 1, so that makes sense. And if, oops, sorry, I clicked the wrong place. I'll take a look at that, Jesus. Good point. So sorry. So I submit the assignment. And then if for some reason I did something wrong or I'm asked to, figure it out, I can click on reselect pages and go back and do it again. So you can always alter it. So let's go ahead and get out of there. Hey, Seuss, you said I put the fall 2020 schedule somewhere. That is good to know. Let's take a look. Is it on the syllabus page?
I think it might have been on home.
Oh,
I don't exactly remember.
sure. Is it, sorry. Is it here possibly? Well, it looks like winter.
Oh, I may have clicked on the wrong one then.
It's okay. So just if you find it later on, let me know where it is and I'll fix it. But you can definitely find the right calendar on the syllabus at the very kind of bottom of it, right there. Yeah, but it is definitely possible. It could be a file somewhere. Like if you look in files, it could be somewhere down here. I don't know. Mason, I'm not. Oh, Alessandra, I have a question during the homework. So by twos means, yeah, you start with the number that's given. So if it's like 14 through whatever by twos, it's 14, then 16, then 18, every second problem. If it's, and I only ever assign things by twos or by fours. So you always start with the first number given, and then you go to the next, second, or fourth problem. So it'll be all the evens if it's by twos, or every other even if it's by fours. Yeah, fair question. I know that can often be a point of confusion for people. Yeah. All right, that is all I wanted to really say. So hope I'm going to end the poll. Hopefully people can see my board better today. I did, so after class ended yesterday, Zoom did ask me if I wanted to update my Zoom. So it might have just been that things weren't updated. So hopefully once I start writing on the board here, things will look all right. I should also close my iMovie so that, because that's definitely, I can hear it sucking up some of my my computer's ability to process. Okay, so let's go ahead and so we'll continue on with class A, talking about lines and parabolas, and then we will hopefully get to class B. And where did you go, class A? I just had you open. Do you hate it when you have a thing open and ready to go and then it just disappears because you were probably screwing around in the place you needed to be? Sorry, 1 second. Let me grab the notes. Yes, there we are. Okay. Hopefully everyone's having a good second day of class. I know most of your classes probably don't meet 4 days a week. Usually 3 days a week is pretty typical, but this class is special. So let's go ahead and continue on. So we talked about last time finding the slope of a line, finding the equation of a line through 2 points. Just a couple last things to say about lines. It's titled Course Calendar under Modules. Oh, okay. No, you're probably right, Jesus. I probably didn't update that. I will get that mod fixed after class. Good point. Yeah, I did, as I think I mentioned last class, I definitely did copy this Canvas shell from last quarter. So it is definitely possible that some of the things are accidentally not updated. So if you find anything else like that, feel free to let me know. So last couple things about lines. And again, not that we've said everything there is to say about lines. We're kind of just going over the very broad basics here. The last couple things are, if two lines are parallel, then their slopes are the same. So for example, here are some parallel lines. Y equals 2x plus 5. Y equals 2x minus 18. And 3y minus 6x equals 5. That equals 12. All of these lines are parallel because all of them have the same slope. Here the slope is obviously 2. Here the slope is obviously 2. And here the slope is less obviously still 2. If you solve for y here, you would see that the coefficient of x was positive 2. And then we also have that, how do I want to say this? If 2 lines are perpendicular, so perpendicular is never a fun word to write. It's way long and, hard to spell sometimes. We often just use this symbol to say that the lines are perpendicular. So if 2 lines are perpendicular, which I will write this one time, perpendicular, their slopes are opposite inverses, or reciprocals if you prefer that word. So you can say opposite inverses, you can say negative reciprocals and mean the same thing. So opposite meaning opposite sign, reciprocals meaning the flip of one another. So these 2 lines, y equal to negative 3/2 x plus 7, and y equal to positive 2/3 x plus 19. These are perpendicular lines, and we can see that because their slopes are the opposite sign. One's negative and one's positive, and they're flips of each other. One is 3/2, one is 2/3. One is negative 3/2, and one is positive 2/3, I should really say. And that's kind of it when it comes to perpendicular lines. Actually, so that's not quite it when it comes to parallel and perpendicular lines. So 2 lines can be parallel and have the same, or 2 lines can be parallel without having the same slope if they're both vertical, because in that case their slope is undefined, so they don't technically have the same slope, because it's weird. And 2 lines can be perpendicular if one's vertical and one's horizontal, and then they're not really opposite inverses. It's just their slopes are 0 and undefined. So that's actually the very last thing I want to say about lines, is that y equals c, where c is a constant. So like y equals 5 or y equals negative 7 is a horizontal line and has slope 0. And it kind of makes sense if you think about the slope of a line being the rise divided by the run. If you have a purely horizontal line, there is 0 rise, right? It doesn't get higher or lower. So you have a 0 rise over a very large run. And 0 divided by any non-zero number is just 0. Similarly, x equal to a constant, like x equal to 4 or x equal to negative 2, is a vertical line. And has an undefined slope. For the same sort of reason that this has a 0 slope, a vertical line has an undefined slope, because you've got 0 run, right? It's not moving left or right at all, but it has a lot of rise. So here, the rise over the run is a large number divided by 0. And dividing by 0 is undefined. So here, vertical lines have an undefined slope, horizontal lines have a 0 slope. Not that we've talked about functions yet, we certainly will in the future, but I'll just point out that any line is representative of a function except for a vertical line. Vertical lines are not functions. Okay. That was kind of the last couple things we had to say about lines. There are, I will say, so I have certainly not covered lines fully, I would say, right? There are more things to say about lines, but what I will say is there are a lot of videos in Canvas. If you have more questions about lines, you can certainly watch. All right, let us move on to talking about parabolas. So there are two different forms, or two different typical forms of the equations of parabolas. So forms of the equation of a parabola. One way of writing this, probably the more standard way. Oh, sorry, sure. You good, Fernanda? Does it say long? Oh, sorry. It says large. So, right, the rise could be any number really, right? If you go from, like, say, this point to this point, but it could be super far, right? So if you're finding this, right, finding the slope between 2 points, well, no matter what 2 points I pick on this horizontal line, right, the rise will be 0. I really should say the run on the bottom. A better way to say this would be that the run is just non-zero. Because that's more accurate. It could be a small number, it could be a big number, but 0 divided by any non-zero number is going to be 0. And in a similar way, over here, I could really say that the rise between any 2 points is non-zero, and the run is 0. And the non-zero number divided by 0 is undefined. Any number divided by 0 is undefined, whether it's 0 or non-zero. Hopefully that clarifies things. You're welcome, of course. So there's two ways typically of writing parabola. There's either y equal to ax squared plus bx plus c. And there is y equal to a times x minus, we use h or k, h squared plus k. I forget what names people use specifically. I think this is usually called the standard form. This is usually called the vertex form, or the completed square form, if you like. So this is the vertex form. This is the standard form. So usually, most of the time, people are probably going to write your parabola like this, which is too bad because honestly, writing it like this is more informative. So just like the slope-intercept version of writing the equation of a line tells us what the slope and what the intercept are, the vertex version of writing a parabola tells us where the vertex is. And the vertex is kind of the most important point of a parabola, in my opinion, in most people's opinion. So a couple things to note about either one of these. First thing to note is that the a here is the same, meaning if I was writing the same parabola in either the standard form or the vertex form, this coefficient would be the same value in either one of these equations. Nothing else would be the same, but this would be the same. So if this was like a 2 here, it would also be a 2 here. So the a value is the same in both equations. And the second thing to note in the vertex form is that the point h comma k is the vertex of the parabola. So those are the kind of, so if the parabola is written this way, we know what the vertex is going to be. So let's talk about a couple examples. Sorry, let me give you guys a moment. I will admit I do write kind of fast sometimes. I will try not to go too fast. Let me go employ the trick of erasing the other side of the board while I give you a moment. The downside of not wearing shoes is sometimes you stub your toe. Okay, so first and foremost, the graph of y equals x squared. This is kind of your standard parabola or your parent function when it comes to parabolas. All parabolas you could think of as coming from this one. I don't usually graph it super precisely, but you could if you wanted to. I typically, if I was going to try and graph it more nicely, I'm going to plot the points 0, 0, 1, 1, and 2, 4, and negative 1, 1, and negative 2, 4. Those are the 5 points I would usually graph. And then I would try and make it look parabolic. So it shouldn't just be like straight down and up because you have like some nice smoothness to it. And again, you can obviously also use Desmos to look at what graphs look like. I think that's a great tool to use. I encourage everyone to use it. Some things to know about this. So for either form, right, for y equals ax squared plus bx plus c, or y equal to a times x minus h squared plus k, if a is positive, then the parabola opens upward. Like this one, right here, the a value, which we haven't written down because we don't when it's 1, but the a value is 1, that coefficient's 1, and this is opening upwards. On the other hand, if a is negative, then the parabola opens downwards. And we'll see some examples of that in a moment. But yeah, when I see a positive coefficient, I'm usually thinking, okay, it's going to look like this in some way. When you see a negative coefficient, I'm thinking it's going to look like this in some way. And all parabolas pretty much have the same sort of shape, like this, either opening up or opening down. Sometimes they're wider or narrower, but they're always this. They look like this and nothing else. There was something else that just crossed my mind that seemed worth mentioning and already has disappeared. I hate when that happens. So, yeah, there really was something else. Oh, I know what it is. So just to point out, parabolas are always going to come from quadratic functions, right? Where you have a polynomial, meaning a function where you have powers of x that are non-negative and integers, right? You don't have any weird fractional powers. You don't have any weird negative powers. They're all positive integers. And the highest power is 2. That's always going to result in this kind of graph. Okay. Oh, I grabbed the wrong eraser. That one's funky. So how to graph a parabola, because that's really kind of the thing I care mostly about. So I want to graph, say, the parabola y equal to x squared minus 2x minus 8. And so just like with graphing the lines, there's kind of a process that I think is the most expedient that's going to get everything we want. So for lines, we graph the x-intercept and the y-intercept, and we draw the line through them. For parabolas, there's typically 3 things I'm going to look for, one of which might not exist, which is fine. So the things we want to find in order are 1, find the vertex. 2, find the y-intercept. And 3, if they exist, which they don't always exist, but if they exist, find the x-intercepts, which there may be 1 of, or there may be 2 of, or there may be none of if they don't exist. So how do we find the vertex? There's a couple ways of finding the vertex, but usually the easiest way is to use the fact that the x coordinate of the vertex, so which I typically call v sub x, that's the x coordinate of the vertex. We usually find this as negative b over 2a when it's written in the ax squared plus bx plus c form. So in this particular problem, our a value is 1, our b value is negative 2, and our c value is negative 8. So we want to find the vertex here. That's going to be negative negative 2 over 2 times positive 1, which ends up being 2 over 2, which is 1. Now, something to remember here, that's only half the vertex. Right? That's the x coordinate. I need the x and y coordinates. So I'm going to plug in that 1 to my parabola equation to figure out what the y coordinate is. So I'm going to say that v sub y, the y coordinate of the vertex, is the x coordinate of the vertex plugged into the equation. So it's 1 squared minus 2 times 1 minus 8, which ends up being 1 minus 2 minus 8, which is negative 1 minus 8, which is negative 9. Do be careful, right? If you try and do the subtraction the other way, this isn't 2 minus 8, it's negative 2 minus 8. So negative 2 minus 8 is negative 10, and then 1 minus 10 is negative 9. So our vertex is going to be the point 1 comma negative 9. The y-intercept, we always find the same way, no matter what kind of thing we're graphing. You're always going to find the y-intercept by setting x equal to 0. If I set x equal to 0, when it's written in this form, it's really, really easy. If x is 0, I get y equal to 0 minus 8. It's always going to be whatever the constant term is here. So I'm going to get y equal to negative 8. So I'm going to get 0 and negative 8. And to be honest, at this point, before I even think about x-intercepts, I like to start graphing it because it's going to tell me if I have x-intercepts or not. Let's see, my parabola, my vertex is 1, negative 9, my y-intercept is 0, negative 8. So 1, negative 9, let's say it's about right here. So there's 1, negative 9. And then 0, negative 8. Is 0, negative 8 going to be a y-intercept that's higher or lower?
Higher.
Yeah. Now, here's what we know about the vertex. The vertex of a parabola is always either the highest point if it's opening downwards or the lowest point if it's opening upwards. This is clearly the lowest point, right? It can't be the highest point because this point's higher. So it's the lowest point. We know it opens upwards. You can also know it opens upwards because you've got a positive coefficient here. Either way, we can see that it has to go this way, which means we do have x-intercepts. On the other hand, if we had had a vertex here and we had a negative leading coefficient, then we would have seen that it opened downwards. We would be like, oh, there's no x-intercepts. We don't need to bother finding them. So the reason I think it's good to graph these points before you think about x-intercepts is because usually at this point, you can tell if you even have to try and find them or not. So you can save yourself some work of trying to find them and finding out there aren't any. But there are, so we should find them. So to find the x-intercepts, we're going to set the whole thing equal to 0. So set y equal to 0. So I'm going to get 0 equal to x squared minus 2x minus 8. And a lot of the time, maybe not all the time, but a lot of the time, this will factor nicely. It does here. This factors as x, and let's say I'm trying to multiply it to negative 8 and add up to negative 2, which is going to be a negative 4 and a positive 2. Now don't fool yourself here, right? That doesn't mean the intercepts are negative 4 and positive 2. It actually means they're the opposite signs. The intercepts are going to be x equal to positive 4 and x equal to negative 2. Because if you plug in 4 here, 4 minus 4 is 0. If you plug in -2 here, -2 plus 2 is 0. So my intercepts are -2 and +4. The other thing that should always happen is that if you do have X intercepts, they should be equally to the left and right of where your vertex is. So this vertex is at +1. My intercepts are 1, 2, 3 to the right and 1, 2, 3 to the left. So if things don't look symmetric in that way, it means you might have made a small error. And then we try our best to draw a nice parabola, which is sometimes easier said than done. That's all right. It's not the best, but you know. But it definitely shouldn't look too pointy around the vertex. It should kind of smooth out and curve down and then curve up. Questions about any of this before we do another example? Time is it? We got time. Ow. It's real fun hitting my toe on this thing. Be more careful.
Someone has a question about step 2.
Oh, sorry. Thanks. How can you see there are going to be X intercepts by graphing? Great. So the way I typically do it one of two ways. I either, when you graph the vertex and then look at the leading coefficient. Since the vertex is down below the x-axis and the leading coefficient is positive, which means it opens upwards, if we're below and opening up, we have to cross the x-axis. Alternatively, you can compare where the vertex and the y-intercept are. If the vertex is below the y-intercept, it's the lowest point, so we have to open upwards. If the vertex is above the y-intercept, it's the highest point, we have to open downwards. Those are the two ways that I think about doing it. Yeah, let's do another example, which I think might help. Now I have to think of another example. Let's say we wanted to graph y equal to -x squared plus 4x. Let me see, b squared minus, sorry, make sure the numbers work out right. 5. Yeah. Cool. So let's go ahead and do all the things. Let's find the vertex. So the x coordinate is going to be -b over 2 times a. Right? A is -1, b is +4, c is -5. So you get -4 over 2 times -1. That's going to be a +2. And the y coordinate, I'm going to plug into for x. So I'm going to get, so be careful here. I'm going to get -2 squared plus 4 times 2 minus 5. All right, this one can be kind of tricky. This -2 squared, -4 or +4? Well, it's actually -4, right? Because it's not this, right? If it was -2 quantity squared, then it would be +4. But there isn't any parentheses there. And the order of operations say we do exponents before we do any subtracting. So that squaring has to happen before this negative sign. So you get 2 squared, which is 4, and then it's -4. So I end up getting -4 plus 8 minus 5, which is -4 plus 8 is +4, and 4 minus 5 is -1. A trick I've learned with parabolas over the years is that when you're plugging back in your x coordinate of your vertex into the parabola, this first thing is always the opposite sign of the second thing. And it's always half as much. First thing is the opposite sign of the second thing, and it's always half as much. Always totally, completely true. So you should always be looking for these to be opposite signs if you're finding the y coordinate of the vertex. That's the only time that's true. Okay, so my vertex is the point 2, -1. And the y-intercept, if we set x equal to 0, we're going to get y equal to 0 plus 0 minus 5. So my y-intercept is 0, negative 5. We also know from this negative leading coefficient, or coefficient of x squared, that it's going to open downwards. So let's plot the things. So I've got the point 2, negative 1. And I've got the point 0, negative 5. So there's my vertex. It's either the highest point or the lowest point. It's got to be one of those two things. It's got to be the highest point. 1, because we know it opens downwards. 2, because there's a point lower than it. So seeing that, and in fact, we can even graph it. Which is not my best graph ever. Oh, well, in fact, that's we should try that again there. But graphing it, we can see that there are no x-intercepts. If we tried to find them, we wouldn't be able to factor this. If you can't factor this, you can try using the quadratic formula. But if you try using the quadratic formula here, you're going to get no real number as a solution, right? If I try and solve this where a is negative 1, b is 4, and c is negative 5, if I try and set that equal to 0, my solutions would be x equal to negative b plus or minus the square root of b squared minus 4 times a, which is negative 1, times c, which is negative 5, all over 2 times negative 1. And the problem here is that the inside of the square root is negative. Right? 4 squared minus 4 times negative 1 times negative 5 is 16 minus 20, which is negative 4. And the square root of negative 4 is imaginary, and we're not going to deal with that. So this one doesn't have any solution. But what I'm trying to do is save you this work, right? You don't have to do this work if you can look at this and be like, oh yeah, there's clearly no x-intercepts. So don't do work you don't have to do. That's often the theme of my teaching is don't do work you don't have to do. All right. Yeah. Let's look at one more question. Sure. So let's say we've got two things. We've got the graph, we've got the equations y equal to negative x squared plus 6x, which is definitely a parabola that opens downwards. And we've also got y equal to 2x plus 30, which is a line. And first and foremost, I want to find the points of intersection. So we're trying to find where two graphs intersect. We're trying to find a coordinate x and y that satisfies both equations. For example, if x is equal to 0, y would be 3. But if x is equal to 0 here, y wouldn't be 3. So x equal to 0 is not a place where they intersect. We have to have both the same x and y coordinate. And the way we usually do this, if we have them both solved for y, is just set the y's equal to each other. So we're going to set 2x plus 3 equal to negative x squared plus 6x. To see what values of x make the values of y equal to each other. So I'm going to bring everything to the side where my highest power has a positive coefficient because I think that's easiest. So I'm going to bring everything to the left. I'm going to add x squared. I'm going to subtract 6x. 2x minus 6x is minus 4x. And then hopefully I can factor. I can multiply the 3 and add up to negative 4 with x minus 3 times x minus 1. Right? Negative 1 and negative 3, multiply the 3 and add to negative 4. And then the solutions are x equal to +3 and x equal to +1. So that's not quite the whole solution, but that's most of it. I wanted to find the points though, right? X equals 3 is not a point. It's half a point. I need the y coordinate. So I can plug x equal to 3 back into either one of these equations and I should get the same y value. So I plug it in here, I get the point 3 comma, let's see, if x is 3, y is going to be 2 times 3, which is 6, plus 3, which is 9. I would also get the same thing if I plugged in 3 here and get -3 squared, which is -9, plus 6 times 3, which is 18, and -9 plus 18 is 9. So you can pick either one. If you pick either one, you usually want to pick the easier one. And then we're also going to get, if we plug in 1, 2 times 1 is 2, plus 3 is 5. So those are the places where these parabola and this line intersect. And then the second part is I actually want to draw it. So how precise do I want to be? I should probably be fairly precise. So I'm going to graph the line first. The line, I can find the y-intercept and the x-intercept. Or I can find the y-intercept and say I've got these other points as well. I've already kind of got a lot of points. So let's, sure. And I'm not going to be super precise. So here's my y-intercept at 0, 3. And then I've also got the point 1, 5. Not my best line ever. I know the line and the parabola are going to intersect at the point 1, 5 and the point 3, 9. And 3, 9 is actually the vertex of the parabola. How do I know that? It's a good question. Well, if you look at this parabola, we could find the vertex. The x coordinate is going to be -b over 2 times a. -6 over -2 is +3. And we know the y coordinate is going to be 9. Right? If you plug in 3 here, you get -3 squared plus 18, which is 9. So this is the very top of the parabola. So it's going to kind of look like this. Whoops, kind of. Actually, it goes right through the origin. Sorry. I've drawn better parabolas. You guys are like, sure you have. You keep saying that. Goes to the point 0, 0. It also goes to the point 6, 0. And we can see that by setting -x squared plus 6x equal to 0 to find the x-intercepts. Now, one thing I want to say about this. You really don't want to solve this by bringing this over and dividing both sides by x. What you want to do is you actually want to factor. Here, since we don't have a constant term, we can just factor out an x. Well, I'm about to answer that question, Mason. It's a good question. So I factor out an x. I've got x times, I'm still left with a -x here and a +6 here. So the solutions are either x equals 0, because 0 times anything is 0, or x equals 6, because -6 plus 6 is 0, and 0 times 6 is 0. So my solutions are x equal to 0 and x equal to 6. So that's why this parabola specifically goes through the origin, because it's one of the intercepts, the x-intercepts and y-intercept. Or we also could have just found the y-intercept. If we plugged in x equal to 0, you'd get 0 plus 0 for y. Other questions about this? The last thing I want to say is there are a couple of homework questions sometimes where you're asked to shade the region enclosed between two functions. So in this case, it's going to be the enclosed region between these two graphs is this part right here. Where, and I know it's kind of hard to see, but where how do I say the words the right way? Where the area you're shading is bordered only by the graphs of the things you've drawn. So I wouldn't want to shade like this part here, because this part here also has an axis as a border, which we did not specify, right? So if you're trying to find trying to shade the region enclosed by two graphs, it should only be bordered by the graphs you are given. Sure, so the way we graph the parabola is, and so I will fully admit, I kind of did this graphing of this parabola kind of out of order because I started with the line and I knew what some of the points were. But typically the way we would graph this parabola is we would first find the vertex. The vertex was the point 39 right there. Secondly, which I didn't actually do, I should have found the y-intercept. The y-intercept, if I plug in 0 for x, I get y equal to 0. So that would give me this point. Now in this case specifically, I'm not going to bother checking to see whether or not I have x-intercepts because I obviously do. Because the origin being a y-intercept is also an x-intercept. So then I would just find the other x-intercept by setting y equal to 0 and solving for x and getting x equal to 0 and x equal to positive 6. There are other ways you could do this one that might be a little easier, but that's the kind of the general procedure for finding the graph of the parabola. Yeah, what time is it? Never enough time. So let me do, it seems silly to start a new section. So let me do one more problem here. And then, yeah, and then I'll need a minute to talk about logistics. So let's graph one more parabola. We're going to do it slightly differently. We're going to use what's called the completing the square method. So let's look at this y equal to, what have I got here? X squared minus 4x minus 5. Now we could totally find the vertex the usual way by doing negative b over 2a and then finding the y coordinate. But instead I'm going to do what's called completing the square, which is something we don't usually do for parabolas, but we definitely do when we're trying to find the equation of a circle. So it is good practice, even if we don't really use it for this particular thing. So to complete the square, you kind of ignore the 5 or the constant term. Some people like to actually put it over here for a second, which I find personally odd. That's okay. You don't have to do everything like I do it. So here's what I'm going to do. Yeah. I'm going to look at this part right here, and I'm going to kind of write the 5 out here. So to complete the square here, I'm going to divide this negative 4 by 2, and then square it. So negative 4 over 2 is negative 2. Negative 2 squared is positive 4. I'm going to add that 4 in, but I can't just add 4. I'm also going to subtract that 4 off. So here's what I've got, which is still the same equation, just written differently. I've got y equal to x squared minus 4x plus 4. And then minus 4 minus 5 is minus 9. Now the reason I've done this is because this can be factored as some quantity squared. If I'm looking for numbers that multiply to 4 and add up to negative 4, those numbers are negative 2 and negative 2. So this can be rewritten as x minus 2 times x minus 2, or x minus 2 squared minus 9. And now we can see that the vertex is positive 2, negative 9. Too high. So there's my vertex. We do know it opens upwards, so we're going to have x-intercepts. So the way I got the negative 4 over 2 is because that's the process for completing the square. Is you take the coefficient of x, you cut it in half, and then you square it. The y-intercept, if I set x equal to 0, I'm going to get 0 minus 5. So I'm going to get y equal to negative 5. So it's going to look like this. we clearly have some X-intercepts, which we should find out what they are. Depending on how you've got this. So we can certainly find the X-intercepts by setting this equal to 0. This certainly factors. Kind of running out of room, which is typical on this one board I have. If we set this equal to 0, this factors as x minus 5 times x plus 1. So we get x equal to 5 and negative 1, which definitely looks like what we've got. Right? That certainly seems like it could be 5. This definitely seems like it could be negative 1. So there's another example. I don't expect you to use this method to graph parabolas necessarily, but yes, that's exactly correct, Mason. Completing the square is one way of finding the vertex. Using negative b over 2a is another way of finding the vertex. Both are correct. Both work fine, but I will point out, completing the square is really nice as long as the coefficient of x is even. But if that's an odd number, then you have to divide it by 2 and things start to get messy. I will also point out that if you have a non-1 coefficient here, so if this number here is something other than 1 or negative 1, completing the square also gets messy because you have to divide that number out first, which I know we didn't do just now, but that is another thing. So typically we default to the other method, the negative b over 2a way of finding the vertex.